Hello and welcome to my YouTube channel. Today in this video we are going to talk about the fundamentals of RTC, or we can say real-time clock, and we are going to emphasize more on the RTC present in the STM32F446RE microcontroller. So let's start the video. First of all, the question that should come to our mind is, what is RTC and where we can use this peripheral? To answer that, RTC basically, or real-time clock, is a hardware or a peripheral module which is inside the microcontroller, and it is used to keep the track of a system's current, not only time, date, and even the calendars. So that means this module can keep track of system's current time, date, and year. Even it can manage whether the year is leap year or a normal year. It can operate on an independent low power clock source, and generally these are crystal oscillators which are connected to the microcontroller, and they maintain a very accurate time. So, what are the general features of an RTC? Some of the most important features are timekeeping. That means it can keep track of current time in hours, minutes, seconds, and even days in terms of days, month, and year. Second best feature is it can work in low power consumption mode also. That means the microcontroller may be in sleep mode or deep sleep mode, but we can keep the RTC running to keep track of the time. So these devices or modules can operate in low power mode, which is ideal for battery powered applications. For example, designing sensor nodes and so on. Third best feature is it can go for battery backup based system, or it can be you can design a battery backup system where you can use external battery or capacitor to continuously keep the time running in these modules. So even if the microcontroller is in the power down mode, these modules can take source or power source from external battery or capacitor to keep track of the time. It can be used to generate alarms, so that we can configure alarms for different periods or for different time, and using that we can generate alarms for wake up signals based on date and time. It can maintain the record of leap years and daylight saving, which is mostly used in European countries where they have two different time zones. Okay, or during the winters they may have different time, and in the summer they may have different time. So basically it supports automatic leap year correction and can be programmed to adjust for daylight saving. So these are some of the general features of RTC. Now coming to the technical specifications of RTC present in STM32F446RE microcontroller. So this RTC can work at 32.768 kHz external crystal oscillator, and therefore it can consume a very low power from the battery, and it maintains a very accurate time. Second feature is it has got its own date and time register. So basically two 32-bit registers contain the details related to seconds, minutes, hours. Apart from that, additional 32-bit registers are there that can be programmed to generate alarms on subseconds, seconds, minutes, date, or a particular time. it has got the feature of alarm functionality. So there are two programmable alarms with interrupt function available in STM32F446RE microcontrollers RTC. The alarm can be triggered by combination of calendar fields like a date or time or hour or date, so on. It has got the feature of wake up timer. That means automatically it can wake up a unit or any other peripheral, generating a periodic flag that triggers automatic wake up interrupt. So using these peripherals or this RTC, we can trigger any other peripheral unit to wake up. It has got independent clock source. So RTC, which is present in the microcontroller, can operate independently from the main system clock. That means you can have two different clocks, one for the RTC, the other for the system clock or the microcontroller's clock. And it ensures a very accurate time even if the main system is powered off. This is very important. Even if the system is powered off, RTC still can maintain very accurate time for the system. Apart from that, we can have the facility of synchronization with a very great precision. It can work for low power batteries or low power modes. Even it can be used for battery backup power supply. So it can use a very small coin cell or a small battery which can be providing power to these modules, which will be separate from the main microcontroller's power supply. And like I said before, even if the main power supply is off, these modules can run separately to keep track of time. And it has got the feature of calendar function. That means it can track time down to seconds and calendar down to century. That means it can keep track of years even on the basis of centuries. So whether it is a leap year, a normal year, or what is the length of the month, everything is managed by this particular RTC. And it has got small SRAM that can store user data and configuration parameters that are retained even if the device is power off. That means it has got the facility to store the configuration and keep it there even if the power is disconnected. So let us talk about some real world applications and projects where one can use RTC. For example, if you want to design a smartwatch, in that case, RTC can be used to design smartwatches and clocks because they maintain a very accurate time and they consume very low power. So they can be used for wearable devices like your wristwatches and even digital clocks. Second project that we can think of is data logging system, where the data from a temperature sensor or any other sensor can be recorded remotely and autonomously, that can have its own time and date stamp, which can be used for analysis or later programming or processing. It has got, for example, we can design a project to manage the power, in which if we require a very low power sensor node, in that case we can make IoT sensor nodes or devices to go into sleep mode or low power mode, where the RTC will be keeping track of the time, and RTC will wake up the system whenever we require some data from the sensor or to trigger some other device. So in that case, the main microcontroller will be either in sleep mode or low power mode, and whenever you need to request any peripheral to work at a particular moment or a particular time, the RTC can wake up those modules on the basis of the time recorded in the RTC. We can use them for home automation systems, where we can turn on the lights or turn off the lights, or similarly turn off any other appliances on the basis of a specific time of a day or month of a particular year. We can design alarm systems where RTC can trigger alarms or events based on a particular time or date, making them useful for security systems. And we can even design automotive systems where we can integrate these RTCs into vehicles for maintaining time in information systems, for example sound systems or car stereos or any other uh, playback systems. Even we can use them in dashboards and telematic units when we need very low power from these systems. Okay, some other one example we can take in consideration is temperature data logger with RTC. So suppose if you want to keep a log of temperature of any environment, then we can use RTC to maintain a log which will be recorded at a particular after every particular interval. So it can be used in any embedded system for environmental monitoring using temperature sensor or moisture sensor. So DHT11 can record both temperature and moisture of the environment, or you can use any other temperature sensor like LM35, okay, which will be connected to the main microcontroller STM32F446RE micro, and the RTC ensures accurate time stamping of the record of the temperature in the environment. Then RTC can provide a log of current time, and that log can be used for further processing. Remember, RTC provides a very precise timing, and based on that we can enable precise data tracking over days or week without losing accuracy of the system. So if you want to record very long logs of data, then in that case RTC is one of the best solution, because it will perform its task iteratively, maintaining a very accurate time period. For further reading or further details related to the RTC present in the STM32F446RE, I would recommend you to download the reference manual of the microcontroller and go to the chapter number 22 related to RTC. So here you can see chapter number 22, real-time clock, and please go through this RTC's detail which is provided in the reference manual. And here you can make note of all the main features which I have not discussed in this presentation, or otherwise this presentation would be a very long presentation. So you can just download RM0390 revision 6 and make note of all the important features of the RTC. With this, I would like to end the presentation. If you have not subscribed my channel, then I would request you to please subscribe the channel and press the bell icon so that you will get notifications as soon as I upload a new video. and please press the like button if you like this video. If you have any suggestions or comments regarding this video or any other video in my playlist, then please share your comments and thoughts in the comment section. Thank you and have a nice day.